All right, we're going to look at Unit 6, Section 2. There's really a couple parts to this, but I don't think you're going to struggle with it too much. It's just a little bit tricky with some of the actual calculations, but we'll go through it step by step. So first thing we're going to look at is adding and subtracting radicals. Now with these, you just have to remember that they're almost like combining like terms. So the first thing you've got to do is make sure all your radicals are simplified to begin with, and then you're going to have to look at radicals with the same index and the same radicand. Only those can be combined. It's almost like saying 2x can be added with 2x. So if you have like radical 2 or 3 radical 2 plus 2 radical 2, it's the same thing. Those can be combined. Those are like terms, essentially. So that's really all it is, and subtracting is the same way. So the only thing you have to remember is to add the coefficients, and then the radical stays the same. So I'll show you, or what's under the radical stays the same. So it's almost like a common denominator or something like that. So we've got, in number 1, we've got 3 square root of 27 minus 2 square root of 12. So the first thing you've got to do here is simplify those radicals. So 3 square root of 27, that square root of 27 can be broken down into 9 times 3, which will allow us to take out the square root of 3. So I have 3 times 3, or square root of 9, which is 3. So I have 3 times 3, and what is inside our radical will be 3. So that will actually reduce down to 9 square root of 3. So I'm going to move that over here. So 9 square root of 3. Now we do the same thing for 2 square root of 12. We need to reduce that. So 2 square root of 12 can be rewritten as 12 can be rewritten as 4 times 3. That will allow us to take out this square root of 4. So we'll have 2 times 2 square root of 3. So that's going to give us 4 square root of 3. So we've got 9 square root of 3 minus 4 square root of 3. Now you can see that we have our radicals have the same index, it's just the square root. And what is actually inside of our radical, or the radicand, is the same. So we can take 9 square root of 3 minus 4 square root of 3, and we'll end up with 5 square root of 3. So you just add or subtract your coefficients, and your radical just stays the same. It's just like if we were saying 9x minus 4x, we would get 5x. You do the same exact thing, except instead of x, you have the square root of 3. And pretty much with 2, 3, 4, 5, and 6 on these, the only difference is that you have a cube root on some and a fourth root. And to simplify those, you're really just simplifying them. You're really just going to simplify them down so that you can combine some of your terms. So that's really it. I'm not gonna really give you too many of the adding and subtracting, I don't think. But yeah, I'm probably only gonna give you like 1 or 2 of those, but I think you'll be okay with them. So now let's look at multiplying these. So when you're multiplying, to me, multiplying's far easier. I think adding and subtracting is the most difficult because you have to simplify at the start. But with multiplying, there's really no simplifying that you have to do. You can just multiply these. So the steps for doing this is to multiply the coefficients of your radicals, then just use the product rule, which says if we have two radicals that we're multiplying, all we do is just multiply a and b, or whatever under our radical. So let's look at 7. We have got square root of 27 times square root of 5. This is simply the same thing as the square root of 27 times 5. So we're just pretty much taking what's inside those radicals, multiplying them, and that would give us 135. The only thing you have to make sure to do is reduce whatever you have. So we can actually simplify this. So we'll get the square root of 135. And that's step 2 that we're on now, is that's this to simplify the radical that we get. So we've got the square root of 135. We can break that down into the square root of 9 times 15. That's going to allow us to take out this 9, which is the square root of 9 is 3, and 15 would be left inside of our radical because we can't break that down any further. So that would be our answer. So the process of doing this is not very complicated. I'll do a cube root just to show you, but it's literally the exact same thing. So if we're taking 2 cube root of 9 times 5 cube root of 24, first thing we're going to do is multiply those coefficients, which would be 10. Then we would multiply 9 times negative 24, which, let me see, I don't know what that is off the top of my head. 9 times 24. That would be the cube root of negative 216. And we don't have to break that down at all. Negative 216, the cube root of that would just be 6, I think. Let me make sure. Let's see, math. Negative 216. Yeah, it'd be negative 6. So we'd actually end up with 10 times negative 6, which is just negative 60. So multiplying these is pretty easy. We're going to look at one additional thing real quick, though. The only time that these become really complicated is when you multiply these and they have variables with exponents. But we're going to use these. We're just going to use our rules for exponents to do these. So we've got the square root of 6x to the 4th times 5 square root of 8x to the 5th. Yeah. So to multiply these, first we're going to multiply our coefficients, which our first term is just a coefficient of 1, so we're going to have 5. Now we're going to multiply 6 and 8. That's going to give us 48. Now, the last part of this is to multiply x to the 4th and x to the 5th. Now remember our rules for exponents. When we have variables and we're multiplying them, we add those exponents. So this will actually give us x to the 9th under this radical. Some people would make the mistake of saying x to the 20th, but that wouldn't be true. You have to make sure to remember those rules of exponents. Then to simplify this, we would keep 5 on the outside. First thing we're going to do is break down 48. We need the greatest perfect square that's a factor of 48. So that would be what? Let's see. That'd be 16? Yeah. So we could break 48 down into 16 times 3. We'll just leave x to the 9th because we'll worry about that in a minute. That's going to allow us to take out this exponent, or the square root of 16, which will be 5 times, let's see, that's 4. And what's inside of our radical would be 3x to the 9th. So that's going to give us 20 radical 3x to the 9th. So just pause and write that down because I'm going to erase some of this. So we got to 20 radical 3x to the 9th. Let me rewrite all this. For some reason my pen doesn't want to write well. Okay. Now we have to worry about taking the square root of x to the 9th. And we can break this down by, just remember that your index is 2. So anytime you have a square root, we can take x to the 9th. And we need 2 x's to bring out 1 x outside of the radical. So since there's 9, we could look at that as, we know that if this were x to the 8, we could take out 4 groups of 2 that are inside of 8. So that's going to give us 20x to the fourth, 3, but we only, since it's x to the ninth, we still have that 9, or that 1x that remains, so it's going to stay inside of our radical. So our final answer would be 20x to the fourth times the square root of 3x. Another way you could look at this is some people would say, okay, x to the 8 times x is the same thing as x to the ninth, and there's 4 groups that can be taken out. If we were to group x to the 8th in groups of 2, we can take out x to the 4th, and then that x would just remain inside of our radical. So that's another way to look at it. Or you can just write out 9x's. This is what some people do. And then they circle. So if you want to do it this way, I'm fine with that. We need we need groups of 2 to take out of this. So we've got 1, 2, 3, 4. So that would give us x to the fourth outside of our radical, and then whatever remains would stay in the radical. So that's just another way to look at it. And that is multiplying radicals when you have variables with exponents under your radical. And we're not going to do anything with these binomial examples, but we are going to go over dividing radicals. So dividing radicals are very similar to multiplying them. You're just going to use the quotient rule, which says that if we're taking the square root of two things that are divided, we just rewrite them both as a fraction under the radical, or we divide them. So let's look at number 1. First, you're going to divide your coefficient. So 12 divided by 2 is 6. Then we're going to have 160 divided by 5 under the radical. So we'll have 6 times the radical of 160 divided by 5, which 160 divided by 5 is 32. So after we divided this, we would get 6 radical 32, but we can break that down further. So we can break that down into 6. 32 can be broken down into 16 and 2. So that allows us to take out the square root of 16, which is 4. So we'll have 6 times 4 times the square root of 2, which is 24 square root of 2. So that would be our final answer there. So division is pretty much the same as multiplication, except you're dividing. Now, the big thing here you've got to watch for is just the same way with multiplying, you've got to watch for those exponents. You've got to watch for your exponents or your variables with exponents on dividing as well. So if we wanted to divide these, we're essentially saying x to the third divided by x to the second. So if you remember, when we divide two variables with exponents, we actually subtract those exponents. So our answer here would be x to the 3 minus 2, which is just x. So we would have the square root of x left over from x to the third over x squared. Then we would do the same thing with y to the ninth and y to the fifth. The only thing you've got to remember is they stay under a radical. So y to the ninth divided by y to the fifth is actually saying y to the 9 minus 5, which is y to the fourth. Now we can reduce this simply because that y to the fourth. There's two groups. So if we have y to the fourth and we need these grouped into 2's, we can take out 2 groups of y's. So that would be y squared on the outside, and x would just remain on the inside. Or like I've said, you could look at this as y times y times y times y. We need 2 groups of y's to take out if we have just a square root. So that would give us y times y, which is y squared. So that's why we got y squared on the outside. But that's all we're going to worry about with dividing. Just remember your rules for exponents when you're multiplying or dividing these radicals. And I don't think you'll have too much problem with these, and the homework answer or homework problems are going to be pretty straightforward. But we'll also do some examples in class.